Slip this down in here and dividing the cylinder into two parts. But now the flame will burn on as long as you leave that cardboard in. Because what has happened is that the warm air started up, and it started up one side first, and that started a convection current up here, and cold air came down the other side.
Well, how do you know that it goes down this side and up this side?
Well, I don't, Earl, but if I put my finger over there and try both sides, it gets warm here, so I know the warm air is coming up this side now, and the cold air is going down there.
Well, to test that, if we take this out, why then very soon the flame should die down again, because the oxygen, again, will be...
yes, if that's tight at the bottom, it will.
Oh, there it goes. I get this back in. I may be able to get it back again. There they come. Well, there she comes. In other words, we set up a convection current again so that we reestablish the same thing as before. Well, let's go back over here and look at this boiling water that we have here in the paper cup and see what's happening. Well, she's still boiling merrily away. Can we dump that into the...
see if I can keep from burning myself here.
Turn it upside down, and on the bottom, hardly any indication that the piece of paper, just plain typewriting paper, has been in this flame all this period of time.
Yeah.
Certainly very striking.
Well, now, Earl, we come to the third method of heat transfer. Many of you've gotten up sometimes in the morning and seen the sun come up over the horizon on a clear morning. And just as soon as you see the light, you feel the heat from the sun. Now, this shows that from the sun, heat has traveled with the same speed of light, and that's 186,000 miles a second. So when I said radiation is fast, I meant fast. It travels with this enormous speed.
Now, this that you have over here, then, is a heat measuring device.
Yes, this is a thermopile, Earl. There's a little metal horn, or reflector, and in the back of this horn are a lot of little wires. Now, these wires are arranged so that when heat falls on them, they develop an electric current, tiny electric current. And that current, through these wires, goes to a meter here, which we project on this screen.
Oh, yes.
And you see the pointer of this meter here? It moves when I turn this horn. It's a detector of heat. Now, if I point it at the floor, you see it shows in the center reading a reading of 0.
Yes.
Now, if I point it toward your face, see the needle go over the right?
Is that my face that's doing that?
Well, that's because your face is warmer than the floor. Now, if I point it at the wall back here, it goes back toward 0 again.
Oh,
Point it at my face, it goes up. Back at the floor. Now, in my hand, it goes up again. Anything that's warm is indicated by the movement of the pointer.
Well, that's certainly a very accurate method of measuring heat. Coming back to something that we've known for many years, a heating device, radiant heat, the old-fashioned fireplace. Of course, down at the bottom here is where the fire would be, and then we have a chimney that comes up here. The important thing about the fireplace is, again, convection currents. Most of the heat comes up here, and by radiant heat, or reflected heat, we get the heat coming out into the room by means of such things as fire bricks in the back of the fireplace.
That's right, Earl. And of course, the radiant heat is what heats up the room. All of the convection currents are up the chimney, and that's fortunate because in that warm air is a lot of carbon monoxide with poisonous gases, and it's a good thing they do go out the chimney. When you face a fireplace and the fire is burning brightly, you'll feel it on your face, and if you turn your back to it, you'll see that the heat is cut off from your face. So we get there an indication that the radiant heat are light waves traveling, and when they hit your face, they're absorbed or hit your body and changed into heat.
So what we have then in our fireplace at home is very much the same sort of thing that we saw demonstrated in this experiment a little bit before. In other words, convection currents going up the tube, and without the convection currents, of course, you wouldn't be able to have a fire in the fireplace any more than this flame would be able to stay there for just a slight second. Now, there's one other type of heating that we haven't mentioned yet, and that's panel heating. It's a newer thing that's just come in, and according to engineers, it's very, very satisfactory and economical. Now, just how does this work, Harvey?
Well, in panel heating, Earl, you have a similar principle to the fireplace. You have a large area that's warm, like the brick walls.
Yes.
Only here, you warm the floors or the ceiling or sometimes the walls by hot water in pipes. This warms up the whole floor area, the ceiling area, and the warmer areas radiate heat toward the people, the occupants of the room. Even though the room may be quite cold, this radiant heat, when it hits your face, hits your body, it's absorbed and becomes heat, and you feel quite comfortable.
Well, this final experiment that you have over here, this gear that you have is certainly very interesting. Those big reflectors, just what is all of this gear now? Can you give us an idea as to how this works, Harvey?
Well, Earl, here we have a large metal reflector, the kind you have in a searchlight. And at the focus of this searchlight mirror, we have one of these thermopiles. Now, way over across the room,
Way down the other end of the laboratory, about 30 or 40 feet down there, isn't it?
yes, you'll find another mirror down there. It's just like the one we have here. And Bob Bell has a candle flame ready to put in this mirror. Now, when he puts the candle flame at the center focus of this mirror, it acts like a searchlight. It reflects the heat rays as well as the light, and we have a beam of heat rays and light coming across to this one. Here they're again reflected and come into the thermopile.
Oh, yes, now we'll see it on the galvanometer there.
And we'll see it on the little pointer of the galvanometer as it moves. Now, Bob, if you'll put the candle flame in, we'll watch the pointer. See it move over, Earl?
There it goes over.
That shows it's receiving heat here. Now, will you take the candle flame away, Bob? See it come back again?
Coming back once more. Can we do that another time?
Over it goes. Now take the candle out, Bob. See the pointer come back again.
Well, just how far could you separate these reflectors now and still get that sort of a reaction on this meter?
Well, Earl, we could put that candle flame 100 feet, a mile, 2 miles, 5 miles, even 50 miles away if it was a clear day, and we could pick up the heat from it and bring it over here and receive it. As a matter of fact, astronomers use thermopiles to detect the heat radiation from stars, believe it or not, millions of miles away.
And then they mount equipment, something like this, in their telescopes and are then able to get a reading.
Yes, they reflect the light or through their refractor, bring the light to a focus from a star on a little thermopile and record the current from it and measure the heat radiated by a star millions of miles away.
Well, this is certainly one of the most accurate pieces of measuring equipment that I've ever seen. And looking back over these demonstrations that you brought to the laboratory, it seems to me that it boils down, again, to these three basic issues. First of all, conduction, secondly, convection, and third, radiation. And no matter where we turn in our everyday lives, we're going to come up against these factors that have to do with heat.
That's right.
Well, I want to thank you again for coming to Science in Action to bring these wonderful experiments, and I see your assistant, Bob Bell, is still wrestling with a mirror down there. Thanks also to Bob for helping with these demonstrations.
It's been a pleasure, Earl.
Now, I'll be back in just a moment with the animals we eat. This is the skull of our animal of the week, and as you can see from those large teeth, it's a rodent, a burrowing rodent, and directly underneath it is the size of the newborn youngster. Very, very small, just about the size of the skull of the adult. You've probably guessed what our special pet is that we have here in the laboratory. It's a pet California gopher. This one happens to be the special friend of Bill Amsball. Bill, you have a carrot there. Would you see if you can put it down in here? And what do you call him? What's his name?
Dig.
Dig. Oh, fine. Put it over here and let's see if he's interested in it. This is unquestionably one of the tamest gophers that I've ever had an opportunity to see. He's not quite sure whether he likes that or not, does he? Oh, he's pushing it over in the corner there. How long have you had him as a pet now?
Oh, about a year.
About a year. You want to put some of this down here over on the side and see what happens very easily now.
He's out.
Yeah, there he goes. See if he's interested in that oatmeal. I know sometimes he fills these pouches with that. Of course, gophers don't see very well. They do hear, however, extremely well, so that if you happen to come upon one that's working in your front lawn, if you don't step very carefully, he'll know that you're there, although he may not be able to see you. Notice this very short tail. Now, that's quite important to the gopher. He's a little bit, doesn't want me to demonstrate that tail, but notice how short it is. That's, again, quite important to the gopher because it enables him to run backwards in the burrow. Now, he's washing himself there now. Oh, you cute little rascal, you. You know, gophers make wonderful pets, although when we find them in our lawn, why, we usually want to get rid of them. Now, not all gophers have the appearance of this fellow. I'd like to show you some other color patterns. These are study skins. This is a Milano. This is a desert form here. You can see the difference. And here's an albino. Now, in the eastern United States, they have a gopher that is somewhat different from our western one. Here are the two types, and the main difference is in the size of the front feet. Notice the size of this big foot. This is the eastern gopher, the smaller size of the foot of the western gopher. Principal differences between the eastern and the western gophers. Well, let's see what our fellow Dig is doing here again. Seems to be quite interested in this. How often do you feed him, Bill?
Oh, about twice a week or so.
Twice a week. Well, he's really a good pet, and this is his normal cage that you keep him in. Well, I hope you'll keep us advised as to how Dick does in the future, and thanks very much for bringing him to Science in Action. Now, here's a type of equipment that we'll have an opportunity to examine a little bit more closely on our next program when we look at our radar defense system. Our special guest on the program at that time will be Brigadier General Andrew of the U.S. Air Force. We hope you'll plan to be with us then. Thanks a lot.
You have just seen another in the fascinating television series, Science in Action. Science in Action is produced by the California Academy of Sciences under the supervision of Dr. Robert C. Miller.